Cargo to the sea. Most underground rivers do not end up in caves, but continue to flow toward the ocean, and almost all rivers above the ground end up in the ocean too. During their travels, all rivers pick up sand and soil that they drop farther downstream. But usually the salt and other dissolved minerals are not dropped. They remain in the water as it flows into the ocean. Yet the river water that flows into the ocean is fresh water. It does not taste salty. But if you have ever gone swimming in the ocean and swallowed a mouthful, you know that ocean water is very salty indeed. Why the ocean is salty? Why is ocean water so much saltier than the river water that flows into it? Here is a way to find out. Experiment. You will need a drinking glass, 1/4 glass of water, 1 heaping teaspoon of salt, and a dish. Your experiment will work a little faster if you use a dark dish. Do this. Add the salt to the water and stir until the water is dissolved. Pour the salt water into the dish and put it on the windowsill. Leave it there until all the water has dried out of the dish. You can speed up this experiment by putting the dish in a warm, sunny window or on top of a warm heat source, radiator. After the water has disappeared, examine the dish carefully. You will find that tiny white grains are left on the dish. These are salt grains, as you can prove by tasting a few. This is the salt that you stirred into the water at the beginning of the experiment. This shows that when water and salt together are warmed, the water will evaporate, but the salt will remain behind. River water, containing tiny amounts of salt, as well as many other minerals, keeps pouring into the ocean all the time. The sun shines on the wide ocean and heats the water. Some of the water in the ocean is always being evaporated by the heat of the sun, but the salt always remains behind, as it did in your experiment. So each day, as the river waters pour into it with dissolved minerals they have carried off from the land, the ocean becomes a tiny bit saltier. The sun steadily evaporates the water. The salt and other minerals stay behind. This has been going on for millions of years, a long time. The minerals steadily washing out of the land into the sea. And that is why ocean water tastes so much saltier than the river water that pours into it. Water goes around and around. The salt stays in the ocean, but the water has an endless way to go. After it has been evaporated by the warm sun, the water is carried high up in the air to form a cloud. A wind may catch that cloud and blow it, perhaps to the coast of China, or over a jungle in Africa, or perhaps even right over the mountain from which it started long ago. But somewhere or other, that cloud will be chilled by a cool wind. Then it'll turn back into water once again and come pattering down on the rooftops of Hong Kong, or frighten a family of monkeys hiding in a coconut tree, or send a family of picnickers running back for shelter. Perhaps it will fall on a thirsty wheat field and seep through to the water table beneath. Or it may once more fill up the spongy soil on a mountainside and then come trickling down as a tiny brook that joins other brooks to form a river that flows to the sea, thousands of miles away. Around and around it goes on its continuous way. This never-ending path is called the water cycle. Over and over again, water keeps making its journey from the clouds. The water you used to wash your hands this morning is millions of years old, and it has made millions of journeys to and from the clouds and has traveled millions of miles. Perhaps long ago it turned a water wheel in a mill in Vermont, or it was churned into white foam by Columbus's flagship, or floated off the coast of Greenland, part of a huge iceberg, or shone as dew on a lilac leaf. It may have pushed a few grains of sand onto the banks of the River Nile in Egypt, or dripped off Abraham Lincoln's hat as he walked alone in the rain. You might have rolled it into a snowball or seen it steam out of a pot of soup. It might have been in the mud puddle your dog played in last week, but each time the warm sun lifted it and made it pure and sent it up into the clouds, ready to fall again, clear and fresh upon the earth. Whether it flows over the ground in rivers and lakes or through rock passages and caves underground, water travels the same journey over and over again. It falls, it flows out to the sea, the sunlight lifts it up to the clouds, it pours from the clouds onto the earth and into the earth, and flows out to the sea again. It is never still. Over and over, water falls and rises from the clouds to clouds, forever freshening the thirsty earth in its endless journey. Mountains unmade. Water swirls and splashes, and rivers are never still, but mountains never seem to change. You read about explorers struggling across the Rocky Mountains 100 years ago, and those same mountains are still there. The narrow passes are still too perilous to cross in winter. Patrols are needed to warn of ice and snow on the Donner Pass between Nevada and California, where so many pioneers and gold seekers lost their lives long ago. But though they seem so very lasting, mountains constantly change. You already know about one mountain changer: water. You saw that moving water could carry along sand, sharp bits of split-off rock, and other materials if it moves fast enough. The water that flows swiftly down a mountain brook with these sharp pieces in it works like a giant saw or like very sharp sandpaper. The water cuts deeper and deeper grooves in the brook's path so that deeper and deeper cracks and notches are formed. The water files away at the rock, cutting out bits of it all the time until the whole mountainside is covered with scrubbed out wrinkles and cracks. Day after day, water files away at the cracks and notches in the rock. Finally, a piece is split off and swept away. A piece of mountain has been worn away and carried down. Bit by bit, ravines and gorges are carved out of the mountainside. Inch by inch, the rushing brooks cut down the huge mountain. High land is cut down by water. Water can also carve high level land into the shape of mountains. This is happening in many parts of the world, and the largest example of it in this country in the Grand Canyon of the Colorado River. Someday, flowing water may cut down and across the high rocky land until there is no longer a Grand Canyon, until all the land is cut down to the level of the sea. Not only in the Grand Canyon, but wherever rivers flow, land is being cut down. Rivers of ice to the sea. You know about the work of running water as it chops down mountains and wears away highlands. But did you know that there are other kinds of rivers which also carve down and carry away the land? These are rivers of ice. Most rivers begin as falling rain, but a river of ice begins as falling snow, high up on mountains where it is cold most of the year. The snow falls and piles up, and more snow piles up on top of that. If enough snow is piled up, the bottom layers are squeezed so hard that they turn into ice, just as you can turn a snowball into an ice ball by squeezing hard enough. Still more squeezing does something to the layers of ice. Here's a way to see what happens. Experiment. You will need 6 ice cubes, 2 small flat plates of the same size, and 4 heavy books. Do this. Rest each plate on 3 ice cubes. Place the books on top of one of the plates. See which ice cube setup first melts completely. You will find that the ice cubes under the books melt sooner. This is because they're squeezed harder than the others that had only the plate resting on them. In the same way, in a river of ice, the bottom layer of ice, with the great weight of snow pressing down upon it, melts slightly, just enough to become slippery. When it does, the huge mass of ice and snow on the mountainside begins to slide very, very slowly. It becomes a slow-moving river of ice called a glacier.